margin of error is kind of like the give or take. So normally we would just say 68%, but now we can say give or take 3.4%, all right? So we can subtract it to get our lower bound. If you subtract it, what do you get for your lower bound? 0.646, okay? Our upper bound, guys, will just be that point estimate of 0.680 plus our margin of error. So what will our upper bound be? 0.714, does that look right? Okay, so what we're going to make sure we do is, one, make sure we feel comfortable finding our lower and upper bound, but two, every problem is going to say interpret, all right? So hopefully somewhere in there you have room for a sentence, okay? And every interpretation is very, very similar, okay? What we're going to say is, we are 98% confident. We are 98% confident the true population proportion and we could be a lot lengthier, but I'm not going to be, okay? We could say we are 98% confident the true population proportion of those that think partial birth abortion should be illegal, but I'm not going to get that wordy, okay? We're just 98% confident that the true population proportion lies in the interval, and then we'll just do our interval, 0.646 to 0.714, period. We are 98% confident the true population proportion lies in the interval of 64.6% to 71.4%. Okay, so again, my math lab will make that wordier. They'll have in the middle what that population proportion is that we're talking about for that specific problem. It is going to be the population proportion, not the sample proportion, because we're 100% sure the sample proportion's is there, because that's what we started with. Okay, let me show you how we can do this on our calculator. So I actually do it with the second problem, but that's okay. I'm going to just jump right to it. So in your calculator, this sheet, guys, the front will be 9.1 and the back will be 9.2. So I don't know if you guys label yours, but 9.1 will be the front and 9.2 will be the back. And what's nice about this, guys, is the calculator will do all the computing for you. You just need to be able to find that critical value, like singularly on your own, and then to come up with an interpretation. Did everybody get one? Okay. So again, we're going to ignore these numbers, and we're going to use our numbers from this problem that we just did. Okay. Bless you. So in our calculator, the first step says press stat and then scroll to your test, okay? So we're going to press stat and we're going to scroll to test, all right? Notice all these up here are tests. That's actually going to be chapter 10 for us. What we want in chapter 9 are the intervals. So if you notice down in number 7, we start talking about intervals. We want to go down to, for me it was A, it might be 0 for you. But see, we want to go down to 1 prop Z interval. Can everybody find 1 prop Z interval? And again, it might be A or 0 depending on your calculator, all right? So once you find 1 prop Z interval, make sure it makes sense. Like, will it click to you? Are we talking about proportions? Yes. How many proportions are we talking about? Just 1. So that's what that means, 1 proportion, and we use Z in the interval. So we'll hit enter. The first thing it's going to ask you is for X. Well, what was our X? 684. The next thing it'll ask you is for N. What was our N? 1006. And then it'll ask you your confidence interval or level. And this was, if we turn it over to part C, we wanted 98% confidence. So we'll put 0.98 there and you hit calculate. If we rounded to 3 decimals, guys, what would you get for your lower bound? 0.646. What would you get for your upper bound? 0.714. And look what it even found you. P hat. So right there off the bat, you get everything, okay? The only thing, like I said, you're not having to calculate is that Z alpha over 2, which I'll have you do like one time during the test just to show me that you know how to do it, but everything else is right there for you, okay? So let's use this calculator to do this next example. It says, in a survey of 3,611 adult Americans, it was found that 542 have not used their smartphone to make a purchase. Obtain a point estimate for the population or the proportion of adults who have not made a purchase with their smartphone. So remember, the point estimate for proportion is always who? P hat, right? If we don't know the population proportion, the next best thing is our sample proportion P hat. How do we find P hat? He's X over N. All right, how many total people did we ask? It's always going to be that bigger number, right? So the 3,611. And of those, how many said they haven't used their smartphone to make a purchase? 542. What we're going to do is, again, we're going to put it in and just round to 3 decimals. So when you put that in your calculator, 542 divided by 3611, rounded to 3 decimals, I'm keeping it at 1.50. And again, that's just to be consistent. So basically, it's the nearest percent to 1/10 of a percent, right, if we moved it over. All right, B, verify the requirements for constructing a confidence interval. So up until now, guys, this is all we could do before Chapter 9. We could just say, hey, 15% of my sample haven't used their smartphone, so I guess 15% of all of those out there haven't used their smartphone, and that's all we could do. Now we can kind of start getting a little bit more confident. So to verify, let's just focus on the N times P hat times 1 minus P hat. Is that greater or equal to 10? Well, what was our N? You got it. You had to have used it already, right? So 3,611. What was the P hat we just found? 0.150. So we'll do 1 minus 0.150 and see if that's greater or equal to 10. So I'm just leaving that greater or equal to 10 on the right-hand side the whole time, and my calculation's on the left-hand side. If you throw that into your calculator, I think it's even bigger than the other one. I get like 460-ish. Is that what, anybody else throw that in there? Taylor, is that what you got?
I got 460.
0.4, yeah. So 460.4 is greater or equal to 10, check. Okay, and then the other one is just, is N less than or equal to 5% of big N? So is 3,611 less than or equal to 5% of all adult Americans? Yes. Okay, so yes, 3,611 is less than 5% of all U.S. adults. And again, keep in mind, this is all my math lab's trying to have you do, but they make it like a Mad Lib game. You know, you have to have all those drop-down menus. So if you have any questions on what exactly they're asking, email me or bring it to my class and I'll pop it up on there. So usually these are like those sentences where you have the drop-down and you're going to have to fill in your 46.4 and say that it is greater than 10, so the requirement is met. All right, let's do this. Trying to think. I want to make sure we can calculate. Oh no, we don't even have the calculator 90. Notice this 90% confidence interval is one of our key ones. 1.645. So 1.645, 1.96, 2.575 are all going to be often. Let's do it by hand, because this is probably the only time you're going to have a chance to do it by hand, and then we'll just double check with our calculator. Okay. So our lower bound formula, guys, is just P hat minus our critical value times our sample standard deviation. Okay. Our P hat minus our critical value times our sample standard deviation. So again, let's fill in what we know and let's leave a blank for our Z alpha over 2 and we'll come back to that, okay? So what was our sample proportion we found? He was up here. He was the 0.150. So 15% have not used their smartphone, minus, let's leave a blank, and we'll come back and fill him in, okay? And we'll fill in our standard deviation with 0.150 times 1 minus 0.150, all over our end of 3,611. All right, so when you're doing your homework and taking your quiz, you have access to your notes. So if it's 90, 95, 99%, feel free to flip to page 2 and just grab that critical value off of there, okay? So 90%, guys, this is just from page 2, okay? And page 2 talks about how we calculated it. It's the 1.645. That's the one that was perfectly in between 1.64 and 1.65, so we averaged it. All right. Let your p-hat, your 0.150, hang out, and in your calculator, you calculate that. This is your margin of error. Go ahead and calculate that. Rounded to 3 decimals, it's kind of weird. I got 0.010 if I round it to 3 decimals. Is that what you guys get? Yeah. Okay. So what does that mean? It means 15% of U.S. adults have not purchased off of their smartphone, give or take 1%. Okay. Give or take 1%. So for our lower bound, we're going to take our 15% and we're going to take away 1%, and that gives us a lower bound of 0.140. But then our upper bound, all we have to do is take our p-hat of 15% and add that margin of error of 1%. So what do? We get an upper bound of 16%. All right. So on my math lab, they ask you kind of, there's 3 different ways you can show your interval. Sometimes they just say, what's your lower bound? You fill it in. What's your upper bound? Fill it in. Sometimes they have one box and you write it in that interval notation, parenthesis, lower bound, comma, upper bound, parenthesis. And sometimes they just have it with margin of error. So you could write this as 0.150 plus or minus 0.01, okay? But do not forget that they're going to have us interpret everything we find, okay? So what we're going to say is we are 90% confident the true population proportion lies in the interval, okay? We are 90% confident. We are 90% confident the true population proportion of U.S. adult Americans who have never purchased something on their smartphone. You know, like it's going to be wordy about that, but I just say the population proportion lies in the interval 0.140 to 0.16. Okay? We are 90% confident the true population proportion of U.S. adult Americans who have never made a purchase on their smartphone lies in the interval of 14 to 16%. So, notice before we say 15%, or now we say I'm 90% sure it's between 14 and 16%. You can have a little bit of confidence. Bust out your calculator again, because I want to make sure we feel comfortable getting those answers on our calculator. So where do we go? We go to Stat, we scroll over to Test, and we scroll down to 1 prop Z interval, which is A for me. How many total people had not used a smartphone? 542. How many people did we ask? 3611. What was our confidence level? 0.9. And you calculate it, and you'll get 14% to 16%. And what's nice, guys, if there's any kind of inferential question like, oh, what happens when you increase your confidence? Just go increase your confidence. Let me make it 0.99. And what happens to your interval? I go all the way down to 13% and up to 17%. So I'm widening my interval because I'm going to cover my butt. So keep in mind, if you don't remember those rules, you can actually do them. You can actually increase your confidence and see what happens. All right, guys. So the last one here is, it's kind of backwards to me, is they're saying, okay, sometimes all they care about is the margin of error, all right? So on the top of page 4, you'll see that the margin of error, they denote E, is just that second part of the formula that we've been talking about, okay? But I just want to let you know, you rarely need to calculate it. We'll do it on this one problem, and I think there's a problem like that in the test, but a lot of times you can calculate it just from your interval itself. So let's see what's going on. It says, a sample of 1,000 U.S. adults resulted in 18% dreading Valentine's Day. Assuming 95% confidence, what is the margin of error, the proportion of adults who are dreading the holidays? So sometimes you can just worry about the margin of error. So 18% give or take how many? So we're just going to steal that formula, E, and we're going to do Z alpha over 2 times our sample proportion, so P hat times 1 minus P hat all over N. I'm just stealing that formula from above. Again, let's skip the first part, Z alpha over 2, and let's fill in what we know. So the critical value is always based on your confidence. We'll come back to it, but let's fill in our sample proportion, P hat. When we went and asked our 1,000 adults, what was the percent? That is our P hat, okay? You sampled 1,000 and 18% said they dreaded it, so that is 0.18. So up here we'll do 0.18 and we'll do 1 minus 0.18. And then how many total did we ask? 1,000. All right, so who do we not have yet? He's based on 95% confidence, and that's one of those common ones. So what can you do? You can flip to page 2, guys, and look at the Z critical value for 95% confidence. He was the one that was perfectly 1.96. So sometimes they don't want the whole interval, they just want to give or take the margin of error. So what we can do is we can just throw this in the calculator as we see it. 1.96 times the square root of 0.18 times 1 minus 0.18 all over 1,000. Let's round it to 3 decimals. What do you guys get when you put that in your calculator? .024 or 2.4%. So what does that mean? 18% of U.S. adults dread Valentine's Day, give or take 2.4%, and you can easily calculate 15.6, 20.4 are your upper and lower bounds. So sometimes they just focus on that margin of error. All right, so the last concept before we get to 9.2, and it's probably going to cut me off again, is how big is big enough? Like, so can I ask just 10 people, or do I need to ask 1,006 or whatever? So this is kind of like the drum roll. All throughout stats, we've been talking about N needs to be big, big, big. How big is big enough? Here's your formula, okay? And there's actually 2 formulas, and I'll talk to you about why there are 2 and when you know when to use which one. So it says the sample size required to obtain a blank confidence interval for P with a margin of error E is given by this formula. So if you know your sample proportion, then we're going to figure out little n, which is your sample size, by taking your sample proportion times 1 minus the sample proportion times this part, guys, Z alpha over 2 over your margin of error. That's the only part that's squared, okay? This is always rounded up. So I don't know if you highlight or circle things, but since we're talking about n, how many people we're asking, it has to be a whole number. Like you can't have 140.2 people. But 140.2, 140 is too few of people. So you always have to round up to that 141, all right? P hat's a prior estimate. If you don't have a prior estimate, you use this formula, 0.25. Why? Because if you don't have a prior estimate, what's the best thing? The middle. And what's 0.5 times 0.5? 0.25, okay? So it's just taking this formula and using 0.5 as your P hat, okay? This is also rounded up to the next integer. So anytime you find sample size, it's kind of a weird rounding rule. You're going to always round up. All right, this example is exactly what you'll see on your test and exactly what you'll see on your homework, where they'll give you one scenario. They'll ask you, what if we have a prior estimate? What if we don't? All right? So it says, an urban economist wishes to estimate the proportion of Americans who own their own house. What size sample? Right there, what size sample? Notice they're not asking us to find a confidence interval. They're asking us to find the sample size, or N. So that's your hint, like I'm going to use the N formula. What size sample should be obtained if he wishes to estimate to be within 0.02 with 90% confidence, okay? So on A, he uses a prior estimate, so that's your P hat. He uses a prior estimate of 0.675 from a Census Bureau, okay? So we're going to use this formula up here. N equals p hat times 1 minus p hat times z alpha over 2 over e squared. And again, guys, I'm just stealing that from right above. I'm just stealing him from here because we have a prior estimate p hat to use. All right, I'm going to go horizontal. When we looked at that Census Bureau in 2000, how many people own their own home? 0.65. But don't you think things have changed? Yes. Is it a good starting point? Sure. But we might gone one direction or the other. So it's going to just be our starting point. So there's p hat. And then we got to do 1 minus p hat. All right. And then we're going to do z alpha over 2 over e squared. And let's fill in what we know. All right. So z alpha over 2 is always based on your confidence level. Since it's 90%, that's one of the common ones that you can flip back to page 2. 90% is 1.645. And you guys might have those memorized without trying to memorize them, if that makes sense. Like you'll be looking at them so much that you'll just have them memorized. What does E stand for in this formula? If you go back up, E is your margin of error. How close do we want to be within? 0.02, so that is your E there. So we're going to leave that as 0.02. Whenever you see the word within or close to, different words to say, that's your margin of error. All right, if you put it in your calculator exactly like that with parentheses where they are, you're going to get something that's not a perfect even number, but we're going to round up, okay? So if you put in your calculator, beeper bopper beep, you should get 1,484.09. 1,484.09, okay? This is where it feels so wrong, right? But notice it is partially over that 1484, so 1484 is not enough. So we have to ask how many people? 1,485, how many Americans, okay? We have to have a unit there. So what does that mean? It means if for some reason I want to do a confidence interval and I want to be 90% confident, I need to ask that many people. That's how many people I need to survey. All right. Say you didn't go to the Census Bureau from 2000 and you don't have a starting point. You'll have to use this second formula, and you're going to notice something that happens, all right? So we're going to use the second formula because we don't have a prior estimate, okay? So we're going to do n equals 0.25 times z alpha over 2 all over e, the quantity squared. What's nice, guys, is we've done all the hard work already because and this is exactly like how my math lab homework is, your quiz, your test. In part A, you'll have already found your z alpha over 2 and your e. So you'll just plug them in, okay? So we'll have 0.25 times 1.645 over 0.02, the quantity squared. When I do this, beeper bopper beep, I get 1,691.27. Is that what you guys get? Yeah. So what does that mean? It means I need to ask at least that many people. So I've crept over that 1,691 mark, but I can't ask 2,700ths of a person. So I need to ask 1,692 Americans, as wrong as it feels. Does it make sense to you that if you don't have a starting point that you need to ask more people? Yay, nay? I mean, because that could be a good, like, inferential question on your homework or on the test. Why, if you have a prior estimate, do you not have to ask as many people? Because you have a rough idea. You kind of know where you're starting, so you don't need to ask as many. This one's kind of out of the blue. I have no clue, so I'm going to have to ask a lot more people.